This is stage one of the sliding filament theory. First, the action potential arrives, and then when that arrives in the sarcoplasmic reticulum, releases calcium ions, which then bind to the tropomyosin, which is blocking the binding sites for the myosin heads. So that'll go like that. And then your binding sites are revealed and the myosin heads can bind to it.
The myosin filament forms a cross bridge and attaches to the binding site of the thin actin filament. When it binds, the myosin head pulls on the actin filament, pulling it inward to the centre of the sarcomere. This is known as the power stroke.
So this is the binding of the ATP, and the ATP is required to re-energise the myosin head, which is there. The exposure to the ATP binding site, and the myosin detaches from the thin actin, allowing the ATP to bind over there, and this causes the myosin head to return to the high energy state.
Stage 4 is the ratchet mechanism. If enough calcium is available, stage 2 can be repeated. The power stroke, pulling actin filaments past the myosin filaments, will continue in a ratchet-like manner until each sarcomere shortens and the H zone disappears.
No H zone.
The action potential diminishes, which causes the calcium ions to leave the tropomyosin and return back to the sarcoplasmic reticulum. Then this causes the tropomyosin to return to covering the myosin crossbridge binding site. It will stay here as long as the muscle is relaxed.